Alright, time for another giraffephysics.com, debatephysics.com, also video presentation. Anyway, physics. So I've decided it's time, for another email event. We'll just call it that. And to see if we can provoke some of these other science channels to actually deal with this paradox that still exists in the sense that physics wants to have it both ways. They want to say momentum and kinetic energy are conserved when they're not. Okay, just doesn't happen in most every interaction we could speak about. It doesn't happen. And it really means you have to choose one that's real and one that's fake, because and one loses all the time, so you should argue, well, of course the one that loses all the time probably is the one that's fake. So the idea is to send this email to some of the talking science heads. So Veritasium, Steve Mould, Action Lab, Alpha Phoenix, Thunderfoot, Math and Science Guy, Bruce Yerney, Cody's Lab, and if you can come up with some others, that would be great. If you can find their email address is the problem. A lot of them don't have one. So I might start including a form links, links to the forms you can fill out on their websites to talk to them. So I found that for Blue and Brown or whatever his name is. So maybe. So anyway, so I appreciate additions if you think there's somebody who could actually make any kind of impact in terms of responding to this rubbish physics. So I did include a new paragraph, and so I'll read that. And just because of the Steve Mould event, it's right on the subject. So see if we can encourage them to actually look at their colleagues' work and recognize that maybe they should say something because it's garbage as science. So, as an update to the previously made request, Steve Mould made a video basically asserting that levers do not conserve momentum, and this is the argument. Okay, they're making this argument that pulleys and levers, these basic tools, don't conserve momentum, that the energy in isn't the energy out in the sense of any conservation of momentum, and we all know that conservation of momentum is the mantra of physics. It's right in the core of it, and to sit there and say that you can willy-nilly, extract that from being a necessary condition for an experiment it's such a bold claim. It's got to come with bold evidence, and obviously the Steve Mould video comes with zero evidence. Okay. And using a minute physics clip that implied pulleys don't either. So it only implied it. I mean, actually stated that it does conserve momentum, but he implied this was an argument saying that somehow, yes, pulleys behave the same way, except it's completely different. It was just so, it made absolutely zero sense. Anybody intelligent watching that video would just have to, should be stunned, because he used a perfect counter argument in the video to somehow support the argument, which can't make any sense. All right, this contention contradicts 2,000 years of well-established physics. It is disgraceful that scientists are it is disgraceful that scientists are you, I gotta get rid of that you, are going to leave these false claims unresponded to. And so I leave a link to Steve's original pendulum video, Newton's cradle video on the subject of levers, and one of my more recent videos. And that's it. All right, the rest of it's the same spiel as the last time. You can read it on the page if you want to. Link in the description. Link probably in a pinned comment eventually. And I'd appreciate it if you would, the email addresses are all right here. So you just copy, all the email addresses and you paste it in the to part of your email. And then you just grab the subject and paste that into the subject line. And then you just grab this greetings, blah, 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 and you paste that into the text of the email and then send it. And I'd appreciate it because we have to. It has to happen eventually that physics deals with this subject, and they're not dealing with it, they're evading it. Okay, obviously they're not creating any kind of conclusive evidence. They're not testing it to pieces. They're not doing anything to get to the truth at all. Anything. They're not even trying at all. They're doing this. They're wiggling their finger and say, look, my finger's wiggling. Does that prove F equals ma? Yeah, F equals ma. There, I proved it. It's that nonsensical as science. Okay, and it all goes back to the stupid Leibnizian claim that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. When we calculate the momentum, we know one of them only has half the momentum. So how does something with half the momentum do the same amount of work? Can anybody make a rational statement explaining how that actually happens? Alright, so I think that's enough on that subject, so we'll move on to a new, so disappointing, responder to the Steve Mould video that's doubling down. And it's really this one's just too superfluous. It doesn't say anything new. It doesn't say anything Steve didn't already say in terms of, it's about F equals ma, and it's about conserving kinetic energy. When no, it's about conserving momentum, and all you're doing is converting momentums. Levers take big M, little v, convert it into big V, little m. That's all they do. That's all that pulleys do. There is no thing called the mechanical advantage. There's just better ways to apply energy. And so sometimes you need the energy in fast, weak, and or heavy, strong. Spread out or pinpoint. There's different ways to apply energy. Light bulb, laser beam. Okay, but it's the same amount. You see, you get it? No, you don't get it. If you got it, you wouldn't be sitting here being obnoxious, trolly assholes. But yeah, it's just hard to take. It's hard to live in this frickin' universe with all these wasted neurons. That's all you people are, is a waste of neural capacity. Fact. Alright, so this guy's channel is called Citation Not Needed, and he has as his icon the number 404, which is basically synonymous with error. Okay, so anyway, whatever. He's made one video, this is it, and so yes, this isn't a video I have to worry about corrupting too many minds, but it's just absolute garbage, and it doesn't say anything, and it's so stupid in so many little ways that I'll play some of it and we'll just go through it, but it's a nothing. It's just another jackass just going, oh, F equals ma, F equals ma. F equals ma. I'm calling that physics when it's not even anyone's physics. I mean, it was just sort of, in some sort of Frankenstein-y way smashed together somewhere in the 1800s by numerous people. But it was like, you can't even say one person invented that. It's not Newton's formula, so they keep calling it Newtonian physics, and Newton never wrote it. Newton never thought of it that way. Newton thought of force as being explicitly an equality to momentum. He used the word proportionality, but, and he overtly stated, after he says the proportional part in the second law, he said explicitly, twice the force, twice the velocity, 3 times the force, 3 times the velocity. Which is basically just saying, it's completely the same thing. The force will cause exactly the same thing as this mechanical action. So you might as well just think of the force as being mechanical action that you transfer. Alright. I mean, god damn it. This is not brain surgery. This isn't tiddlywinks.
Response video to The Lever Paradox by Steve Mould. So, if you haven't seen that,
annoying. So if you haven't seen that, go over there and play with it and hit the little buttons. It's very exciting. Anyway. Shit. Just hate this shitty planet. Alright. So he's not going to say, like I said, he's not going to say anything. He's just going to pretend he's smarter than Steve Mould, and he can say it smarter than Steve Mould said it. And, He's really not going to do any of that.
Go watch it now, or else this won't make any sense. In the lever paradox, Steve described an apparent paradox that appears when you use a lever, or pulleys, or slopes. Anyway, the paradox was that the relationship...
The paradox is that there's a law of a lever that's forever in terms of how long it's been established as a relationship that works, okay? It's Hooke's law, it's these well-established physical principles, and one of them fitting in all there is the idea of conservation of momentum, that levers conserve momentum. So, you know, two mass going one velocity, one mass going two velocity, same momentums, okay? So you have every reason to believe that will be the product of the lever, that all it's going to do is convert. And now you're saying, no, it doesn't convert, it's only 1.4. And the other asshole saying, no, it's not even 1.4, it's 1.25. You know, it's idiotic.
Between the force he was putting onto the lever with his hand and his hand's resulting acceleration didn't seem to follow his intuition. And so he...
So again, it did follow his intuition to say that, yes, momentum is conserved and the law of the lever works. And then he just made up a fable that it somehow doesn't, because the physics says it. Oh, it's not compatible with F equals ma. It's not compatible with 1/2 mv squared. That's not conserved. So they decide to say, well, in this case, we're going to conserve kinetic energy with zero proof, zero evidence, and no good reason to believe it. Yet I'm just going to assert it, and I'm not going to show it. So in every other video he's ever made, he shows it. Okay, he shows you physical evidence. In this video, fuck that. No evidence.
Asked.
Then I was thinking, like, is there a neat way, like, is there something I can point to and say, look, this is where...
Point to, in terms of evidence, would be the great thing,
Yep.
right? And the very
There
fact...
is. And that's what I'll be doing here.
Fuck this.
And it doesn't depend...
Fuck that. There's the evidence. Where's the evidence? Okay, the fact that in 350 years, since they said 4 pounds dropped 1 foot, 1 pound will drop 4 feet, they have never tested it, ever. It's amazingly bad science.
And on any dynamic systems, spinning objects, or anything fancy at all. First, I have to state this.
So it's not dependent on anything physically real in the universe that you could actually test. It's just dependent on my mathematical variations. Variations. Okay? Variations.
As clearly as I can, because it's relevant for the rest of the discussion. But F equals ma is a definite relationship between three things. The mass of a thing, the force acting on that thing, and the acceleration that thing will experience as a result.
Acceleration is just...
Let's make sure we keep that in mind.
Fuck you. Acceleration is just a velocity. So every single time they bring this crap up, there's something magical about an acceleration. Accelerations are just a change in your velocity. And in very few cases is there anything that duplicates gravity in terms of its consistency and capacity to apply a constant force. You can't even do it. If I told you to accelerate your car at a constant rate, you couldn't frickin' do it unless you had a huge amount of technology to help you. Because you're going to accelerate too much or too little. Because as you accelerate, you have to change how much you're applying acceleration. Because the friction's changing, the whole circumstance is changing all the time. Gravity doesn't do any of that. So this is a very specific formula that only works in a very specific circumstance, and they're trying to apply it to all of physics, and it has just no connection to the rest of the physical circumstances, because it is not an acceleration every second, and it is not any of that crap. There's no squared function in the reality. There's only this idea that there's a quadratic relationship between the distance you travel falling in gravity and the time. The more time, the more distance, and it keeps increasing because your velocity keeps increasing. So obviously, as your velocity is increasing, you're going to travel more distance in a unit of time. But in the units of time, you only get the same little tiny bit of push by gravity. So even if you're going 1,000 miles an hour through gravity and you're only in the gravity for 1 second, you're only going to get 9.8 added. So you're going to go 1,009.8. You're not going to be going gravity will almost be insignificant in terms of its contribution to your velocity because you're going through it so quickly.
So,
I mean, gravity is a time-dependent force. I mean, this should not be a negotiable or debatable subject. It's 9.8 meters per second over 1 second in 1 second units. It's only 9.8 if it's in 1 second units. Not any number of seconds, and certainly not squared seconds.
if we hold something on a hand and we apply a net force,
Right?
then
So
the
we
way
know
that that net force affects the
Shit,
acceleration.
the mouse is just not working today. All right, so we know that this gravity example has nothing. You can use gravity, but it's the same thing as pushing it horizontally, moving the weights this way. It's still the work of moving, causing the weights to have momentum. And the only difference is that you could think of doing the lever experiment here horizontally, okay, pushing things, moving things. And you could just think, well, what if I did it in the wind? So there was a constant wind blowing towards the experiment, and then I did the experiment. And the sizes of the objects was proportional to their masses, so they caught the same wind proportional. Heavy mass, big sail, small mass, small sail. You would end up with the same result. You could duplicate gravity horizontally and perfectly understand that, okay, it's really not about gravity. It's about moving the mass, and yes, you can move it in friction. Gravity is essentially just a kind of friction. The wind would be a kind of friction. Any throwing, you would lose the energy of the thing thrown because it's moving into the wind. That's all it is. Gravity is just friction. Doing the experiment with more friction is doable, but it's preferable not to. So it's probably better to think about the experiment in a horizontal plane and say you have a very slick glass-like surface and you've negated much of the friction. That would be the better analogy. Doing it in a string holding up a lever this way and then applying a force would probably be the best way to do it. Come on.
Of that something is described by the F equals ma relationship. Now, to make
So again, says him, blah, blah, blah. All right, so it's what's described by is, again, Newton's formula, which says F equals essentially momentum. Net force equals net momentum. That's it. It's just an increase in velocity. It's not have anything to do with constant anythings. You don't really have to consider any of that. You're just saying how much time was it in the wind? How much time was it in the stream moving?
To make the next part more obvious, let's split this up a little more. A hand pushes on the thing with force Fh, and a hand will accelerate at AH. The thing feels force Fw from the hand.
So we've
and then the thing
established, through the Minute Physics video that you really can't pretend that the force is different. It's the same total net force. You're just saying I'm going to reduce the force in half and double the amount of distance across which the friction I have to move that force into. So I've doubled the grit of the sandpaper, however you want to describe it. And that's all. So there's nothing here about, there's no doubling of any kind of energy or force. All you're doing is converting it again into something that's more useful. A lighter thing moving fast in reference to a heavy thing moving slow. And you're just saying the lighter thing in one circumstance going fast will be more useful, like if I want to assassinate somebody, then I'm going to use the bullet. And if I just want to squish them and have their guts pop out, well, then I'll use the wrecking ball.
accelerates at AW. Now, just by how we set this up, we know that the forces will be equal. Fw is equal to Fh.
Right, so all this is established. I mean, well established in physics that you have to conserve the momentum. And they just throw it all away and just start squaring one half of the equation. And it's just nonsense. It doesn't happen. It's just not true. You can't make free momentum by dropping light things on one end, and lifting heavy things on the other end. You can't make free momentum that way, and you can't destroy momentum by dropping heavy things on one side and making light things on the other side. You can't do it. If you could make a theoretical ideal lever, you could actually have the recoil of the gun hit one side and you could have the bullet move away 1,000 times faster on the other side. Obviously, we can't make that ideal lever. But everybody's always talked. That's what Archimedes is sort of famous for. Give me a place to stand and a fulcrum to place my lever upon, and I will move the world. I mean, he's saying, I can take advantage of this momentum conservation. Ideally.
And since we make sure that our hand keeps contact with the thing the whole time, the accelerations will be equal. That is, AW equals AH. And because those are equal, we can just write down a simple relationship between the force.
So they're going to concede that if I put 2 pounds in this side and put a 2-pounder over here at the same distance, it'll come out with 2 pounds. I'll get all my momentum back. But if I put a half mass twice the distance, I'll lose 30% of the momentum. And if I put a quarter mass 4 times the distance, I'll lose half the momentum.
Force our hand is applying and the accelerations of both our hand and the weight. But remember that we're talking about applying a force to that thing. So the only reason that this relationship...
So force is just a weight, and it's just about how long you're applying the weight. And you could sort of understand that that's what you're doing with a lever. You could have a lever that's in balance because you put a light mass 2 units of distance, half mass 2 units of distance. And you haven't applied the 2 mass yet. And you're just going to watch that actual event where you put the 2 mass on, and you're going to see the fact that these two things are equal quantities. The 2 mass is going to swing, and then it's going to oscillate if you hang the lever from above. And then it's finally going to stop, and the two things are going to indicate they're totally balanced. It's the same pressure over different units of theoretical, can't say time, distance.
holds is because both the forces and accelerations for our hand and the thing are equal. When we introduce a lever, we break those equalities. The force applied to the weight is still related to its acceleration through F equals ma.
It's the mass that's moving, okay? You're not worried. The gravity is almost irrelevant to the lever oscillating. So if I can, suspend a lever above, the masses aren't doing anything gravitationally interesting, because you're just saying how much momentum am I giving them as angular momentum. And angular momentum is the same as linear momentum, except it's a crooked line. You have to figure that part out, that twice the distance is twice the amount of distance you're going to have to travel in the same time. And so that's all that's deciding. And it's just a little bit of mass of the lever that's switching sides. That's the part that's changing and causing the lever to oscillate. The masses aren't oscillating. The mass of the lever is oscillating.
But now, the force experienced by the weight is no longer necessarily the same as the force that we put in with our hand. And similarly, the acceleration of our hand is no longer the same as the acceleration.
So it's just bullshit, okay? We know that the accelerating rate is exactly proportional to the change in the mass. So the mass is twice the distance away, which means for every movement on this side of the lever, okay, where the mass is that we're applying, that mass moves 1 unit of distance, and the half mass is going to move 2 units of distance. So it's a completely equal proportional relationship, and there's actually no reason to think that somehow the lighter mass has more inertia and can't be moved. It's nonsense. So we'll jump ahead. It's all mathematical bullshit. So no point. I mean, just contrives bullshit, puts it on the board, and then he'll square it for no good reason. Right there, he squares it for no good reason. Takes this formula and squares it for no good reason.
Thing that Steve does wrong here. The thing which underlies all of the errors that he makes along the way in his video.
So he's saying he made errors when he's confirming what Steve concluded, which is the half mass leaves with 1.4 the velocity instead of twice the velocity. So even though there's no good reason, and it violates conservation of momentum, and it violates the law of the lever, and it essentially violates Hooke's law, they're going to claim it's true. And nobody's going to stop any of these morons. I can't do it by myself, quite obviously. I can't stop them. You people have to, say, no, that's bullshit. Let's not do bullshit science. Let's defend real science. Let's not defend made-up fables.
Is implicitly assuming that F equals ma is a relationship which applies equally to any pair of force and acceleration. But if the force isn't something that's directly acting
It's
on an
either
object,
or. It
F
cannot.
equals m.
There's no both here. There's no solution to this problem, this paradox, that makes it possible for you to conserve kinetic energy and conserve the momentum. It can't happen. Anytime you're you're taking energy and putting from one mass into a different mass, you will fail to conserve both. It's always a fact. And this is just such a stupid frickin' argument to pretend there's some resolution where both win. They can't both be right.
ma isn't the correct relationship. His intuition is just telling him, hey, you have a force here and you have an acceleration there at the same point. Then whatever intuitions we have about force and gravity.
So all this nonsense about intuitions and all this other horse shit, and really the nonsense is this very statement of F equals ma, where they can pretend in one circumstance the a isn't squared, and in the next circumstance they're going to square it. And that's the real distinction. You can say 9.8 meters per second, okay, and say of increase in your velocity to associate gravity. You could say 9.8 meters per second per 1 second. Or you can say per second squared. And the two are completely different statements.
Are going to apply here exactly the same way as it does to another part of the system. Because, you know, F equals ma is always true.
So let's just understand, he drew essentially the law of the lever right here, but he didn't formalize it accurately because he put this stupid square on this term as if there's some reason to do that, and there's no reason to do that. It's not Newton's physics.
True, right? Well, no, it's not. If the force is not acting on an object, then F equals ma doesn't apply. And as we can see here, it's obviously not true when we're using levers. The exact relationship between a force and the acceleration depends on precisely which pair of force and acceleration we are looking at.
So this is just gibberish. I mean, he's defending the 1.4 thing and saying that somehow Steve doesn't have it right when that's exactly what Steve is saying. So again, this is just so convoluted, nonsensical rubbish. He's not saying anything here, anything rational.
So, I think the key lesson here is to remember to only apply...
He's a lesson. He's giving somebody a lesson, and he's completely validating what he said by saying he was wrong, but he's right. You can't make any sense out of it.
Intuitions about F equals ma and gravity to the object which we are doing work on. And then we can use that to work out the rest of the forces and accelerations on the other parts of the system. If we do that, we probably won't accidentally conclude that 1 joule equals 2 joules.
So that's what the problem is, right? The problem is if you conserve momentum, you create free kinetic energy, okay? You put 1 joule in, you get 2 joules out. Can't do that. You know, that's what the kinetic energy says. But again, you're doing the same exact thing to the momentum now. Now you're saying you put 100 whatever they called them, foot-pounds in, and you only got 60 out.
And neither will we intuitively expect our hand to move at the same acceleration as an object on the other side of a lever.
Well, we do expect it when the lever is doubling the velocity out on the end. So we expect to move the lever exactly the same on one side and get the two results over here, the half mass going twice the speed or the full mass going 1 unit of speed. That's the completely rational and correct expectation. That's exactly how levers do, in fact, actually function. That is the law of the lever. That is Hooke's law. And all of this rubbish is trying to rationalize nonsense. I don't even know why they're making these videos. They have zero evidence for this crap. They're saying, look how pretty our mathematics is. It doesn't get a right answer. This has nothing to do with, well, here's the experiment and here's my math. See how my math fits the experiment? None of that's here. Complete bullshit. All right, that's it. What a horror. Just you know, I just hate it on this planet. So I can't even bother.
Is how to get in shape fast.
Mentioning this guy because yeah, his channel name is rubbish, so I can't do anything with his channel name. And I hate this.
This is a response video to the lever paradox
Shut up.
by Steve.
Shut up. Okay. Ugh, anyway, so do I need? I don't really. I mean, I've drawn it so many times. There's probably no point going over it again and again and again. So the science and math guy has made a video on gravity again, where he just says shit that's just, you know, this pulling nonsense, and yeah, it's just such garbage. And it, you know, so I probably should make a response to that, but we'll see. See what happens. So anyway, email. So please go to the web page linked, and I would appreciate you sending an email to the relevant parties and encouraging them to pay attention to this subject and try to add something that's called real science to the conversation. That is, real evidence and some coherent recognition that the absolute truth is none of these machines can conserve both kinetic energy and momentum. It's not possible.